And now our TA are compiled 2 additional reading assignment titled DNA of Toyota Manufacturing System, and I don't remember exactly, but the other reading assignment is titled as Behind the DNA of Something. So by reading these 2 additional reading assignments, I hope you to fully understand the core mechanism, how this just-in-time production system works, and how this just-in-time JIT production system works better than conventional MRP system. Okay? And you should also understand the limitation of this JIT production system. JIT is not a magic wand, so it cannot solve every possible manufacturing problem at once. Okay? In previous classes, I was discussing a little bit about the theory of constraint, your book review assignment, right? And we discussed about how this theory of constraint is different from just-in-time, and how this just-in-time and TOC are same, right? Now we reviewed about the core mechanism of JIT. Okay, I'd like to ask a question. How do you think about this JIT compared with TOC? Which one do you think is superior to the other? Which one is better? There is no clear answer, but what do you think? Mohammed? What do you think? Which one do you prefer? TOC and just-in-time? Yeah, you can share with us, not between you 3. What do you think?
I don't think we have to understand the TOC.
TOC?
Yeah.
Okay.
So please explain the shift.
Okay. TOC is all about the goal. Theory of constraint. It's a TOC, right? Sorry. Theory of constraint. You know, you have to deal with the slowest process first. That's TOC. Okay, now you understand what the TOC means. What do you think? Which one is better, or why is the same, or why is it different?
I think the Toyota system is they reduce the waste of the inventory against the TOC. This point is very advantageous. TOC is the controller they make a plan based on the constraint. So if the company very important about the constraint and the emotional scale.
Yeah.
This time, this case is it is better to adjust TOC.
Right. Yeah.
In my opinion.
Oh yeah, that's true. That's true, and very nice observation. And bottom line is, theory of constraint is a theory, and just-in-time is a what? Philosophy. So someone can argue that theory and philosophy is just the same thing, but it is different. It's a theory and constraint. Theory and philosophy. In Okay, TA is handing out your new reading assignment.
So, shouldn't JIT shouldn't be better?
JIT is better?
Shouldn't it be, because every company actually is looking for the production system that actually reduces inventory and reduces waste, and GIT is the it's the perfect kind of system for that actually fulfilling that goal.
Okay, that is very nice question. In my personal opinion, it's a kind of higher philosophy. JIT is higher philosophy compared with TOC. However, you can find out very many similar things. For example, in TOC, the foundation of the TOC is the pure observation of the system. You know, hiking. What's the name of the boy? Herbie? Harvey. Harvey is the slowest chain in the Boy Scout. And by close observation, the most important thing is to deal with the slowest link. Okay? Observation, reasoning, and reaction. It's like just pure logic, right? That's so simple. Okay? And the similar thing is we have in JIT something called takt time. How do you define takt time? You have to find out your Herbie in your system. Herbie's step, Herbie's speed are metronome which orchestrate all the system. So if you would like to reduce the takt time in order to meet the demand, you have to reduce the takt time. How? By dealing with Herbie, right? In that sense, TOC and just-in-time are similar. However, in addition to that, in just-in-time system, in addition to that, it also look into other type of waste. In TOC, is only dealing with the time waste. Okay, so it includes more. It does not consider defect ratio or something like that in TOC, right? But in just-in-time, everything is your object. If something is wasted, no matter what, it's a time, it's a money, it's a space, or whatever it is, it's a waste, and they tackle down to reduce that kind of waste. So in that sense, I personally think just JIT is the higher philosophy compared with TOC. Okay, having said that, but there must be some, and I'd like to ask to you why TOC is in sometimes superior to JIT.
So because in GIT, sir, whenever an accident occurs, so actually there is there is no such clause or something to deal with some unprecedented accidents or something like that. But in TOC, there is also provision for building inventory. So like in case of earthquake or something accident, they actually can deal with that. But GIT cannot deal with that.
It depends. It's a very nice observation. However, sometimes inventory in real life, inventory also, sometimes in a JIT manufacturing system, they try to keep a marginal level of inventory by manipulating the number of kanban. If those variability is so critical, then they increase the number of kanbans. So they can, reducing the inventory, because inventory is waste, so they try to reduce it, but they do not try to reduce the inventory blindfolded, also in JIT. Okay? They try to reduce the inventory as much as they wanted. Okay? So that's one thing. The other thing is, it is true, inventory is essential to absorb unexpected variability in the system. There is no other way. Well, theoretically speaking, there is one way to absorb the variability, which is adapt to your manufacturing system as fast as the variability happens, but which is almost virtually impossible, right? TOC, they do not concern about the inventory, but think of the inventory. They are not trying to intentionally increase the inventory. Okay? The inventory happens there because Herbie is slow. So the other guys are fast. So the producing speed is faster than the Herbie's consumption speed. That's where the inventory accumulates. But when in TOC, if you tackle the Herbie's problem and make him faster, then the constraint, the most slow process, does not disappear. The next slow process now become a new Herbie, right? Then location of the inventory moves to that, right? But amount of the inventory at that case, compare the amount of the inventory when the original Herbie is there. Which one is larger? Original one. So moving constraint tends to reduce the unintentional inventory one by one. No, gradually. Why? And what's the limit? Eventually, the slowest processing time, slowest cycle time, the workstation with slowest cycle time will become the Herbie, right? And when you solve some problem and reduce the cycle time, the new Herbie appears. If you reduce the cycle time again, the new Herbie appears, and eventually all the workstations cycle time will be balanced. And then every process are now the constraint, which is symptom of just-in-time production system. Their cycle time is now the takt time. Okay? So downside of theory of constraint is that you tackle the constraint process one by one to make eventually every possible process in your manufacturing system constraint. It's a kind of irony, right? But that's true, and that's some kind of limitation. Okay. Two more questions. One thing is this. We are in ocean systems engineering, and we are majorly discussing about our manufacturing system, shipyard. And you've already write some discussion about how this theory of constraint can be applied to the shipyard production. And most of the time, the launching system, dry dock or floating dock, or some facility, some workstation which can launch the ship into the water are usually the constraint in most of the shipyard. That's why they first schedule the dry dock schedule, and then every other thing are synchronized with that dry dock schedule, right? And also many people are trying to minimize work inside of the dry dock. by pre-outfitting or by increasing the size of the blocks, making a grand block, which will greatly reduce the work time inside of the dry dough, which is the scarce, most scarce resource in the manufacturing system. It can be regarded as the application of theory of constraint. Okay, that's one thing. But we think just-in-time has many more aspects compared to this theory of constraint. So, how can you apply this just-in-time to chip production system? Think of it. Applying a just-in-time is nothing more than identifying waste and reduce that waste. Okay? In that sense, what do you think the waste inside of the shipyard? Mm-hmm. Mm-hmm. Time. Okay, so how can you improve that situation? Floating dough. Okay. Mm-hmm. Mm-hmm. Okay. Nice thing. But there is more than that. Okay? Identifying waste is, in another word, what is waste? It's about the definition of the waste in manufacturing system. And non-value added something, time, process, and blah 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 are all waste, right? So, first thing first, if your process is non-value added, then eliminate. For example, if your manufacturing system are sequentially consist of five different workstation, and by close observation, number 3 workstation does not add any value, then the most important activity you can do is totally eliminate number 3. If you eliminate the workstation itself, it will save space, right? Other than that, it's a waste of space. You can save worker. Other than that, it's a waste of human work time. Yep. Uh-huh. 2 weeks ago, yeah. Mm-hmm. Mega block. Assembled by block, yes. On the dry dock. Yes, right. That's right. That's why they try to build a bigger block with larger crane. Okay? And yeah.
to any shipyard.
But okay, have you ever been to any type of shipyard? Oh, okay.
How can a manager decide that this workstation doesn't add any value? Because whenever actually design is designing,
Yeah.
he should actually only design only those workstations that are necessary. And afterwards, how can a manager decide that this doesn't actually add value?
Okay. There is some technique called a value stream mapping. It's not mathematical theory or computer software, but it's something called mapping technique. And if you are expert on this value stream mapping, um, you will be ridiculously highly paying expert. You know, many company trying to find the waste, and they trying to find identify where is the waste and where is the non-value added um, workstation or other things. But you know, in their own eyes, because they are working for that company for many years, there is nothing. Everything is essential in their own eye, but with some other consultant's eye, they can actually identify the waste by applying this technique. It's nothing more than just define the final value in your product and how these value are assembled to make a final one. And in your factory's workstation, these values are assembled at this workstation to the final product. So by doing that, you can identify actually value stream. While the raw material passes through your manufacturing system, in many of the workstation, value are added. So, you know, in real world, in nature, small streams are getting together and becoming a larger river, and eventually it becomes an ocean, right? Same thing, value stream. And if you can actually map your value stream to the workstation, then you can build this value stream mapping. After the class, you go to the Google and search it. There are many books who can suggest this value stream mapping. And I'm not going to cover it because it takes more time. But if you can do it, you will be really well-paying expert. Anyway, things like that. Identifying a key feature of your product, and there must be some list of the features of your product, and identify what process or what activity adds those features or value to your final product. Other than that, it's a waste. Okay? Yeah, it's a very easier to say, but there is one example like this. Okay, rework, you know, when you do the welds, and the purpose of the weld is putting two things together, right? But doing weld, the unwanted byproduct is welding distortion. It is distorted. And what? You have to flat it down because that is unwanted thing, right? This, this mitigation of the welding distortion is not value adding activity. So you can, so if I ask you got to eliminate those mitigation process totally, then many workers in shipyard say, no way. There is welding distortion, and we cannot make product with welding distortion. So it is so natural to them, but have to think in another way. Weld it without producing welding distortion. That's the solution. That's one thing. The other thing is, I don't know the exact name of those things, but aligning a block together, it's really, really hard. 500 tons of size of this classroom, and in order to weld it together, welding, everything should be aligned in few millimeters. Okay? Very, very hard. Think of the overall size. 20 meters over 2 millimeter. It's 10 to the minus 5 accuracy. Very, very hard to do. So people tend to add some kind of guides like that. Block A, block B. If you look this way, this guide looks like this. So the outer plate of the other block can be easily fit, and if you just pull it together, it will automatically fit to the right place. Manufacturing these guides and moving this guide around the shipyard and attaching the guide here, and after aligning and welding it, you have to remove the guides. It's a non-value added thing. You got to eliminate this one. So right answer is assemble block together without this guide. How? Got to increase the quality, accuracy. That's the right answer. Right? So there are many, many, many other things. And most effective thing in just-in-time, if you eliminate workstation or process itself, you eliminate part, machine, human work, other than at the same time. Okay? But it's a controversial. Most of the bow structure, which is very narrow at the bottom and flat on the top because it's a deck, they tend to turn it over and do the work. Is it waste? Without turning over, you have to put some kind of support. Have to compare which one is more wasteful. Turning over is waste. It does not add any value. Or putting the support structure is also waste. But we cannot do this one as it is because it will vary. So have to think which one is more wasteful, then you have to eliminate that part. Identifying waste and eliminate that part just in time. Okay. I mentioned 2 questions to ask, and we just talk about the first question. The last question I'd like to ask is, takt time and all this wasting, identifying the waste and eliminate it, and putting end-ons and haijunka, right? You understand what I'm saying, right? All this jidoka and and kanban and many other things, which indicates it's a just-in-time system. But key feature of this just-in-time production system is pooling system. Okay, customer pools the needs. Okay, downstream process is your customer. Next workstation is your customer. So it pulls by sending Kanbans, right? Okay, how do you think we can implement this kind of pooling system in shipbuilding processes? How? Well, simple. Um, According to theory of constraint, the dry dock schedule is the most important master schedule in shipyard. According to meet the dry dock schedule, keep the dry dock schedule, you have to do almost anything in shipyard. If you cannot keep the dry dock schedule, your ship delivery date will be delayed, and it's a huge penalty. Okay? Sometimes if you delay too much, you have to build a ship for free because the penalty is so heavy. Okay? So everything should be done. Overwork or all possible thing can be done to meet or keep the dry dock schedule. The next schedule to consider is grand block schedule. If grand block should be there in order to erect it to assemble a ship. So once the dry dock schedule is done, in this product design, it is divided with blocks, and each block are assigned to the deadline. No matter what, until this date, this block should be there, right? And in order to make that block, those sub-assembly, there are going to be many sub-assembly to make this block. This block should be done until where? Until where? This should be done. But this kind of scheduling is MRP, right? It's a pre-planning by considering the cycle time and time needed or and the like. So it's a very straightforward to us apply MLP system in shipyard. Okay, how can you apply just-in-time philosophy to shipyard? In just-in-time production system, the workstation don't know about their master schedule. Their customer require their product, and they just answer those, needs. That's the just in time. So how do you apply this just in time to shipyard? Mm-hmm. Is used always. Okay. So applying Kanban. Okay, good thing. They are doing in. I'm not sure how this translates into English correctly, but there is right beside of the dry dock, there is a block yard. So in English, it is called platen. The platen is just a big empty space where the grand blocks are just aligned there according to the schedule, so that the erection crane can pick up the block and assemble into the ship. That's the platen. And in Korean, what we call block 적치장. Yeah. Yeah. Or yeah, it direct translation is block yard or something. Okay, empty space. If we keep the MRP, we are supposed to get the work order from the control tower, and according to work order, we are supposed to produce a block at some time, and we have to deliver that block into that platen, into some specific area. But it is frequently happening. Do you know what the transporter is? Transporter in shipyard. Oh yeah, that's not enough. It's a very flat truck with lots of wheels on it, and it can go under the block and lift it, and that's a transporter. And according to MRP system, you get the work order. Pick this block into from some workshop and transport it through this route and deliver that block at this space and at exact time. So according to that work order, you go to there, and there is a block, and you lift it and go there, and there is your space to put your blocks on it. But it is not empty by some delay or before that. How would you do that then? Your transporter driver. In many shipyards, what they do is, okay, right beside of my spot, this is empty. So I put my block there and just report back, I'm supposed to deliver my block into space A, but it is not empty, so I put right beside of it. And in MRP system, the control tower, you have to do lots of replanning because of that disturbances. That's the typical MRP system. The thing is, should be like a Kanban. Okay? Once space is emptied, this emptiness should be the signal triggering those transporter move. So in so by first look, you cannot distinguish from MRP system and just-in-time system being applied. But who triggers the work order? That's the most important thing in pooling system in just-in-time. Okay? Visual signal, Kanban. Kanban could be a container, an empty space, or whatever, which triggers the pooling signal. It's a Kanban. So applying Kanban is the key issue of this applying the pooling system. So by a first look, everything could be same, but who triggers the work order? That's it, which distinguish it's a pooling or MRP system. Even though they give the work order, okay, work order without any specific begin date and end date. Okay, so work order just to describe what kind of activity you should do to complete your job, but this triggering action could come from Kanban. Then it's a pooling system. Okay, what I mean? Okay. Good thing. And in Korean shipyard, you can see many type of andon. What is andon? Yep, it's a something or a lamp which always showing your status from of a worker, of a equipment, of a process or space, whatever it is. Did you see the tires of the many cranes or work trucks running around the shipyard? Yeah. Okay. Um, what they do, it's a very funny thing. If this is just tire of a truck working in shipyard, they colored like this with white and tire are basically black, so they put wire stripes like this. Why? Why do they did this? First of all, it's ugly. But why? What do you think? I think STX is doing the same thing. No? 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 Okay. Samsung and Hyundai are doing this. Why? Because they have plenty of paint. It indicates, more clearly indicates the speed of the vehicle. Right? Right. This is shipyard. A very wide area. So moving truck, 10 kilometers per hour, 20 kilometers per hour, you cannot distinguish by your look. But if you see it, you can tell. It's about safety, right? In many cranes or heavy equipment, there is andon, green, yellow, and red line. That's a very, common thing. And in panel line, when the crane is moving, there is a little melody is coming out of these cranes, right? I think STX is doing the same thing. I don't know, but melody could be different from shipyard to shipyard, but they are playing like something sounds like a cell phone ringtones, which audioly indicates something is moving, so be careful. It's a signal. And down. And I'm not sure you noticed this kind of thing. There is a bolt. Usually there are many equipment and some are bolted together. And how tightly this bolt is secured is very important in many ways. And sometimes they colored like this. Why? If it is loosened, anybody can see and tell this bolt is loosened and it needs securing. It automatically, visually tells its current status, right? Without this sign, you have to, do you know the torque wrench? Yeah. Without this sign, you have to put your torque wrench and measure, oh, this bolt is secured with right amount of torque or not. But checking every bolt is waste of time. So when right torque is applied, you mark it. And if it's misaligned, then it automatically tells its own status. It's a andon. Okay? What else? What else? There are many endongs out there. All these things are came from this just-in-time philosophy. Okay. Other type of characteristic of just-in-time is 지도카, automation. 지도카 means not automatic thing, but it's a more like if something is wrong, it's automatically shut down and do not produce any defect product. Did you see any 지도카 thing in Shipyard? Or any other type of factory? Mm-hmm. Factory, yeah. Uh-huh. Oh yeah. Mm-hmm. Mm-hmm. Yep. Right. Jidoka is automation. The key feature is stop when something is wrong. The basic thing is the stopping line. Even though you're very just a floor worker, you don't have power to enough. You don't have enough authority to many. If you even though you're not the line manager, you can always stop the line when you find something is wrong, which is kind of 지도카. And this is what you're saying. And in, when you go to Home Plus, there is a many cashiers line. And did you notice that there are some other cashier who work not on the same single lane, but usually moving around? And if the cashier say, I have some problem, then this guy are coming and solve the problem. This is also regarded as some application of Jidoka. What else? In many factories, there are sensors there. If something is not properly done, it does not proceed the operation. For example, there is a press machine, but it has sensors. So if the operator's hand comes in, you cannot put it down because it's automatically forbidden. Those kind of things are example of jidoka. And another thing is pokayok, foolproof mechanism. Any idea in shipyard how this foolproof mechanism is applied? Foolproof. Foolproof is even though you're a fool, you cannot do wrong. Very nice thing, right? But making things foolproof requires many brain works, right? In shipyard operation, there are many foolproof mechanisms. What? Just a second, because professor said plate and then right. This is foolproof, okay? But it is kind of bad foolproof because it requires many non-value added things, right? You can do it by, I heard that, I never see it my own eyes, but I heard that in some of the Japanese shipyard, they are doing the exactly same thing without additional non-value added thing. You know, usually block looks like this. You know, in flat plate there is the stiffeners and web frames. Well, I'm not a good drawer, but you know what I mean? This kind of stiffeners and web frames are there, and these one are usually welded on top of the flat plate, and this is kind of sub-assembly, and they assemble this sub-assembly to make a block. Putting these things together, they requires. But if you look here, what the Japanese are doing is, this is base flat line, and this is the normal thing, right? This one. And another things are there, and they have to put it together. But some shipyards are doing this thing. Why? To make it foolproof, easier alignment, without additional non-value added, you know, guides or something. Any other example you can see in shipyard? Foolproof. Okay. Okay. Let's take a 10-minute break at this point, and let's continue on the discussion. Okay. We talked about this just-in-time and TOC, and of course MRP, and many inventory control algorithm or equations. All these things are for facilities planning. In another word, facility planning has consisted of many things. One is finding the right facility location. If you're the, you know, some logistics manager in global corporations such as Intel or something, your factory and suppliers are located all around the world. So identifying right spot for the new factory or new supplier is a big job. Okay, facilities planning consists of facility location problem and facility layout problem and many other. And for now, we are not considering the facility location problem because in shipyard case, it's always given, right? Anyway, let's talk about this facilities planning. Two things: facilities location, and we are not going to consider it in this class. And the other thing is facility design problem. We'd like to design a shipyard or factory, but from what? Well, system, we can design a facility system, or we can design a layout, and we can design a material handling system. It's three main components of facility design. Okay? Facility system, well, it's up to you. What kind of manufacturing system? Even though we are building a shipyard, there are many types of shipyard and many level of shipyard technology. So if you'd like to have a fully automated, high-tech or something shipyard, your system is totally different from less advanced and requires many labor worker type shipyard, right? But you have to choose your level of system. It's from the throughput and your technology level and the existence of highly educated human resource and other things. But anyway, once you define your facility system, using this kind of manufacturing systems, I'd like to build a ship. And then you have to identify and or make up your essential workstations and how you can arrange it within the given space. It's a layout design problem. And what kind of material handling system are you going to use? It's another problem. And usually layout design also and handling system design, you will utilize many inventory control type of calculation. Okay. This briefly discusses about what kind of step do we have to follow in order to design a manufacturing facility. Well, first thing first, in the beginning of the classes, we focused our discussion on product, part, not process and resource. And do you remember what the characteristic of manufacturing system which defines the production system? You know, there is a Bechtel, ExxonMobil, shipyard, right? And number of product you're producing, number of intermediate product, and revenue per design. All these things are originated from what kind of product you produce. So first thing, you have to clearly know what kind of product are you going to produce. Well, I'm a shipyard, so I'm going to make a ship. That's not enough. What kind of a ship? What size of the ship? How many of them? Everything should be clearly defined. For example, I'm going to produce 6,500 TEU container ship, 10 container ship per year, plus some Panama Max tanker of 2 or something. You have to be very, very, very specific. Specific enough to build a major product breakdown structure. Okay? You got to know what is produced. Without what is produced, how can you design a factory which produces that? Right? Second is, we have to specify the manufacturing processes, how we are going to produce that product. There is a numerous other ways to produce something. Okay? You can assemble, for example, this kind of desk. You can bolt it together, or you can weld it together. You can, nail it down. There are many other processes. So it's up to you. What kind of technology level are you going to do? What kind of human resources available out there? And many other things should be considered at these stages. But most of the time in shipbuilding industry, it's very much related to your throughput. I mean, throughput means basically how many ships are you going to produce, right? If you're a shipyard who are planned to produce 20 container ships per year, the processes it requires is totally different of shipyard who makes a 2 container ship per year. In the latter case, you can utilize many workers, but in the former case, you have to invest more money to automated machine. It's up to you, right? So obtain production quantity and estimate resource requirement. That is the key issue. Okay? Because we are manufacturing a thing in order to make money. So if you have plenty of money to burn and economic feasibility is not a concern, you can, build a whole Toyota-like factory just to make a 10 car. Who cares? Right? Okay. Department is a group of workstation. Process are usually makes up a department, but in shipyard or shipbuilding industry, we are dealing with many unique items, so we are introducing something called group technology to harness the similarity between the unique intermediate product. Anyway, you got to define some kind of workstation. The stable processes consist of process and resources, right? But in this case, we introduced a new term called department. And the reason is it's for the layout planning, shipyard layout. Process is somewhat absolute, abstract thing. It's a process. But however, when we call a department is the smallest entity which do something. At the same time, it has to have some space. It requires some space, okay? And interact with other departments. That's the definition of the department. So, information filing is not a department because we can do it without any spaces. It can be run on computer software. So, it's not department, but machining is a department, right? And since department can interact with other department, the most important interaction is flow of material. Okay, you can give you get the raw material and do your process and hands it to your customer, and the next workstation, which is your customer, get that and do their work, and those flow of material is most important interaction among the department. And the next important interaction is information flow. These are 2 students from Changwon SDX. It is very straightforward that if there is a heavier material flow between 2 departments, the right answer is put those 2 departments as close as possible to reduce the material handling. which is non-value added thing basically. But when it comes to think of information flow, well, there is a cell phone, internet, computer system. Why can we put these two in department with heavy information flow together? It's a non-material. Internet can handle it, or this kind of polycom system can handle it, right? But it's a half true. This is why these two guys are sitting here. By telecommunication, we can eliminate the barriers of distance in information flowing. However, it plays still an important role. Close interaction can only happen when it's close enough. Telephone, internet, email, it can help the interaction in terms of information, but it cannot substitute the human face-to-face interaction. Okay, so second most important interaction between department is information. Okay, what else? What do you think? Usually, we only think material flow and information flow when doing the layout design. But it's not because these two things are everything. There are many other things to consider. What would be that interaction between departments? Just imagine you're the owner of a huge money, and in order to utilize your money, you decided to make a factory. Okay? Economists analyze that if you produce this much of this product, you will make a big money. So now it's your job to design a factory. What would you do? Well, you can follow this thing, and while arranging the department in your factory, what would you think? Well, you can hire layout designer expert, but but let's not think of that case. What did you think? What would you do in designing your own factory in layout design? Well, if some department are utilizing very toxic chemical, then even though it requires many material flow and heavier information flow, you have to put it at the corner of the factory, right? Because of safety, right? Or sanitary purpose. If your factory is some sausage manufacturer, okay, your garbage station should be apart from your, food cooking and those kind of things, right? And what I said, first thing is material flow, second information flow, third safety, sanitary purpose, and what? Okay, there are many other reasons. Um, you know, anyone has a car? You two guys have a car, and who else? Okay. Facility layout design also include parking lot design. Did you notice any differences in parking lot in HomePlus or eMart and other spaces? Yep, that's true. That's true. You know, in shopping mall, um, the time spent by the customer within the shopping center is relatively small, 1 or 2 hours, and compared to that time, you know, we want to maximize the customer flow. And in their analysis, parking takes too long time. Then it's a it's a hurry of that process, right? They need frequently parking and moving, another new parking and moving. They need that. So the parking lane itself is very large, and the parking space is also large compared to that. But think of other spaces. Company like the workers drive their car and park there, and they work all day there. And when they want to go home, they just drive away. One park One parking per day is a normal company. In their cases, there is no reason for give a very large parking space because it's not the hobby of their processes, right? So very good observation. Those things are intentionally designed as such. Okay? If the shopping mall, it depends on the type of the shopping mall, and um, the really frequent coming and going out is required. They tends to introduce the sloped parking space. Do you know what I mean? Sloped parking space. Usually, parking space is like that, right? You park here, 90-degree, but sloped parking space means some case the parking spaces look like this, right? It's just easier to park and move back. Okay, there is a many good reason to do that, but one thing is reduce the time, reduce the bottleneck. Okay. Anyway, bottom line is there are many other things to consider, but the most important thing is material flow, information flow. Okay.